Imagine Earth as a giant jigsaw puzzle. It's not one solid piece, but rather split into large chunks. These chunks are what we call tectonic plates. You see, our planet's outer shell, known as the lithosphere, isn't a single unbroken surface. Instead, it's divided into a series of these plates. But here's the kicker. These tectonic plates aren't stationary. They're constantly on the move, shifting and sliding over the Earth's mantle. So, these tectonic plates are not static. They move around, and this movement has some pretty significant effects. Now, you might be wondering, how do these plates move? They don't have engines or sails, do they? Let's dive into the fascinating world of plate movements. The secret lies beneath the Earth's surface. The outermost layer of our planet is divided into a patchwork of plates, like a giant jigsaw puzzle. These plates don't stay still. They're on the move, powered by the heat from the Earth's core. Imagine the Earth's mantle, the layer just below the crust, as a giant conveyor belt. In a process known as mantle convection, heat from the Earth's core causes the mantle to flow in circular currents. This movement pushes and pulls the plates above, causing them to move. But that's not the only force at work. There's also something called ridge push. This happens at mid-ocean ridges, where plates are forced apart as molten rock rises to the surface. The newly formed crust pushes the plates away from the ridge, causing them to move. And then there's slab pull. This occurs when a plate's leading edge is forced into the mantle at a subduction zone. The rest of the plate is pulled along behind it, contributing to plate movement. These processes, mantle convection, ridge push, and slab pull, are the engines driving plate tectonics. They're constantly at work, causing the plates to move at a speed of a few centimeters each year. Through these mechanisms, our Earth's plates continue to move, leading to various geological phenomena. You might think that plate tectonics is an abstract concept with no real-world relevance, but you'd be surprised. Let's consider some solid examples that show how plate tectonics shapes our world. Picture the Earth as a giant jigsaw puzzle, with each piece representing a tectonic plate. Now imagine these pieces constantly moving, albeit very slowly. This movement is responsible for many geological events, including earthquakes, volcanic eruptions, and mountain formation. Take earthquakes, for instance. These are caused by the sudden release of energy in the Earth's crust, creating seismic waves that make the ground shake. A prime example of this is the San Andreas Fault in California. This fault is a boundary between the Pacific and North American plates, and their movement against each other has caused numerous earthquakes over the years. Next, let's talk about volcanic eruptions. These occur when there's a rupture in the crust, allowing hot lava, volcanic ash, and gases to escape from a magma chamber below the surface. One of the most famous examples of this is Mount Vesuvius in Italy, responsible for the historic eruption in 79 AD that buried the cities of Pompeii and Herculaneum. It's located on a complex convergent boundary where the African plate is being subducted beneath the Eurasian plate. Finally, we have mountain formation. This happens when two tectonic plates collide, causing the crust to buckle and rise. The most dramatic example of this is the Himalayas, the highest mountain range in the world. It was formed by a collision between the Indo-Australian plate and the Eurasian plate around 50 million years ago. So next time you feel the ground shake, witness a volcanic eruption, or marvel at a mountain range, remember that these aren't random events. They're the result of the constant, slow, but incredibly powerful movement of tectonic plates beneath our feet. These examples serve as a testament to the immense power and influence of plate tectonics on our planet. To sum up, plate tectonics is the study of the large-scale motion of the Earth's lithosphere. We've delved into the intricacies of this process, exploring how the Earth's crust is divided into several plates that glide over the mantle. We've discussed the different types of plate movements, divergent, convergent, and transform, and how they lead to the formation of various geological features. We've also looked at real-world examples of plate tectonics in action. from the creation of mountain ranges to the occurrence of earthquakes and tsunamis. Understanding plate tectonics isn't just about gaining scientific knowledge. It's about appreciating the dynamic nature of our planet and being better prepared for the natural disasters that can result from these tectonic movements. The more we learn about these processes, the better equipped we are to predict and mitigate their effects. That is the fascinating world of plate tectonics. It's more than just a scientific theory. It's a force that shapes our world and influences our lives in profound ways.